This problem is simply asking us to find a, which is the first term in any geometric sequence, r, the common ratio, which is found by dividing any term in the sequence by the previous term, so 7 divided by 2 will get us the value for r, and it's asking us to put that information together to give us a rule that describes this sequence here. Alright, so it's a very easy question, this one. We know that the formula we're looking at goes like this. Tn equals AR to the power of n minus 1. Our job, to repeat the point, is to find values for A and R, and we're done. So what we do now is note that A is equal to 2, the first term. R is equal to 7 divided by 2, so that's 7 divided by 2, which of course comes to 3.5, and all we do now is plug those, or substitute is a better term, substitute values for A and R into our template up here, the template up there. Okay, so we have the sequence defined by this rule. The nth term is what that means. The nth term is given by 2 times 3.5 raised to the power of n minus 1. There are two ways of answering this question. Find the fourth term for the sequence defined in the previous question. The first way is what you might call the sensible way. We know that so we've got to find the fourth term. We know that the third term, T3, is equal to 24.5. And if we multiply that by the common ratio, which was found to be 3.5, we'll have our answer as simple as that. So T4 would equal that, which comes to 85.75. Now the second way is a more mathematical approach, and that is to use our rule that we found, which is Tn equals 2 times 3.5 raised to the power of n minus 1, and substitute 4 in place of n, and we'll have our answer. So we'd say the fourth term is equal to 2 times 3.5 raised to the power of 4 minus 1, which of course comes to 3, and from your calculator you'll obviously find that T4 equals 85.75 as before. Right, this problem's a bit of a triple bunger. It's asking us to do three things really. Firstly, we've got to find the value of x that makes this true. Sorry, I'm just having a bit of problems with my technology. Oh dear. Right, got that sorted. Now, we've got to find a value of x such that we've got a little geometric sequence going here. Then we've got to find the nth term. By nth term we mean the general rule that applies to this sequence. And then you'll find that that enables us to find any term in the sequence. And in this case we want to find the 10th term. Okay, so here we go. What do we do? Okay, so what we know is that x plus 1 divided by x must equal x plus 4 over x plus 1. Okay, now that must be true because if it's a geometric sequence, a term divided by its previous term will equal any other term divided by its previous term. So that's how we come about this relationship here. So all we've really got to do now is solve for x. It's not as bad as you might think. What we're going to do is cross-multiply our fractions. That's a property of equivalent fractions that you can cross-multiply them and the equality remains the same. Or the equality remains, I should say. So doing that we get this. X plus 1 times x plus 1, so it's x plus 1 all squared, isn't it? Must equal x times x plus 4. So x times x plus 4. Expanding out, you should know how to expand perfect squares. We have a perfect square on the left hand side of the equal sign there. We get x squared plus twice the product of the inside terms plus the last term squared, which is 1 squared is 1, equals x squared plus 4x. You're going to find that the x squareds cancel each other out. There's one on each side. And we're going to take the 2x from this side and subtract it from that side. That leaves a 1 there, and that will equal 2x there. So we can now say, having eliminated the x squareds, that 1 equals 2x. So therefore x equals a half. Okay, that's good. We've answered this part of the question. We found a value for x, and in fact, so doing, we've found a value for a, haven't we? Because x is the first term. All right, what do we do now? Well, we've got to come up with a general rule for this sequence, and let's go to a new slide for that. Yes, all right. So what we know is that we're after a rule that takes this form. And already we know a value for a. A equals a half we found, didn't we? Okay, so how do we find a value for r? Well, r is simply any term divided by its first term, but we know a is a half, and the second term, it was x plus 1, wasn't it? So x plus 1 in this case is a half plus 1, which is 1 1/2, otherwise known as 3 over 2. Now, because we know that the second term is 3 over 2, we can find a common ratio, can't we? So r must equal 3 over 2 divided by a half. Now, when you divide a fraction by a half, really it's the same as multiplying that thing by 2. So we can say, therefore, r equals 3 over 2 times 2. Well, it's just equal to 3, isn't it? So therefore, the general rule for our sequence is a half times 3 raised to the power of n minus 1, and we're done. Now let's move on. We had to find the 10th term, so all we need to do is replace the n with 10 and we are done. So let's move to the next slide. So, Tn equals a half times 3 to the power of n minus 1. So the 10th term is simply equal to a half. You can think of this point as 0.5 if you prefer, times 3 to the power of 10 minus 1 is 9. And your calculator will tell you that the 10th term is therefore, let me work it out for you. Yes, it's equal to 98,000. Whoopsie, lost you. 98,415. Done.